Okay, welcome to the video. So in this video, we're going to address an issue. The issue is that we have our program. The issue we're not going to address is a frame rate. There's another fix to that, but that's not in this video. So here we have it, all well and good. Now, if we minimize this, we get an error. What does it say? QPresent. And it looks like there's an exception code, which is out of date. Yeah. So OpenGL does a lot of hand-holding for us. It creates a frame buffer for us. When we minimize or resize a window, it basically recreates the frame buffer because, well, it all gets destroyed. Well, the Swapchain, I should say. So here in Vulkan, we need to do this by ourselves. I'm going to go through a few steps to recreate the Swapchain. The first thing I'm going to do is a bunch of refactoring to take out the individual steps which were used originally to create the Swapchain so that we can recall those functions. So for instance, if we pop over to the engine, see here we sort of create the Swapchain as well as the Swapchain frames, and then down below we do a bunch more work on the Swapchain frames. So we create a frame buffer for each of the frames. We're doing that here. And then we create a command buffer for each of the frames. And then we go through, and for each frame, we create a synchronization object. Well, you know, the semaphores and fences that we need. So the full Swapchain creation, the Swapchain creation itself is up here. That's no problem, that we can do that in one step. But there are other objects which it wouldn't hurt to sort of recreate them for the frames. So anyway, I'm rambling. Let's extract the basic tasks. So this is making the Swapchain. And for that, we'll just grab. And I just realized we're going to need this stuff as well. So the bundle has all the objects that we need to run these functions, and there we are. That'll get us there. Neaten that up. That's looking nice. Now it's a good idea just to run this and check that it is working with no errors. I'm going to be doing this quite liberally throughout this session. Yep, it's working. Okay, good. Alright, so we have that. I'm happy with that. Make pipeline, that's fine. Okay, finalize setup. So we need the frame buffers. So we'll make frame buffers function. Come on, VS Code, keep up. Okay, so I haven't messed up pipeline too badly. There we have it. Okay, so we'll call that. And again, we'll just check that this is working. Yep, good. Okay, command pool we won't need to mess with that, but we are going to need to mess with this a little bit. See, originally I made one function which takes this set. One of the properties of the set is this set of frames, this list of frames, and as a side effect it loops through the list of frames and creates a command buffer for each of them, and then it returns, allocates a main command buffer and returns that. That's a pretty nifty trick, but it's not going to work here because what are we going to do? We're not going to mess with the main command buffer, but we will create a whole bunch of new command buffers. And as I'm saying this, I realize we probably don't need to create a new set of command buffers, but you know what? I'm going to do it anyway. Well, actually, just thinking to myself, well, technically we don't need to, but because this make frame buffers is allocating a new list of frames, that would sort of overwrite the initial. And it's just one of these cases where we have like 3 or 4 different axes that we're trying to optimize on. And if we make something easier, some work has to be done on the other side. And if we make the other thing easier, then work has to be done on the other side. So given that it's 6 of one or half a dozen of the other, I'm just going to go with this approach of recreating everything. So let's make this make a little more sense. I'll call this make frame command buffers. And for that, we'll remove this bit at the end where we make a single command buffer. And then I'll call this just make command buffer, and this will just make a single command buffer. So we'll just remove this loop. But yeah, it's nothing too crazy. You see, we have this allocation info, which is capable of allocating 1 frame buffer. And here we allocate that a whole bunch of times and store it. And here we allocate it once and return it. Okay, happy with that. So I'll go back here, and what are we doing? What are we doing? Okay, we're going to make a command buffer. And here we're going to make the full set of frame command buffers. Okay, and of course note that here when I do this make command buffer, I'm not actually using the Swapchain frames that I field that I set. That's okay. A little bit of unused data. It's not the worst thing. So we can go and so yeah, we're just setting that up, running that, and that looks pretty good. So I'm not actually going to mess with it down here because I've already set up the command buffer input. That would just be a bit too much. I'm sort of, yeah, we'll go with that. But we will use this function. So I'll make a function called make sync objects. And this is where I'm going to loop through and make everything. Okay. What's up with my voice? I've had a sore throat for a number of days and nothing's happening with it. I don't know what's wrong, but there we have it. Okay, so that is good. But now we have our error. So our error is, of course, we minimize it and it doesn't work. So let's start working on that now. Close that off. That's all good. Okay, so another thing I'm going to do is I'm going to make a function to destroy the swap chain, just the swap chain. Now, yeah, and all the objects for each frame, of course. Now, why do we want to do this? We want to do this because we want to destroy the swap chain when we close the program, and we also want to do it when we recreate it. Destroy the old swap chain, make a new swap chain. So we'll make it into a reusable function. Okay, and that is basically all of this stuff here. So we're looking through each of the swap chain frames, destroying each of their resources, and then we are destroying the actual swap chain. So see, this video is sort of a remix, so just remixing the old stuff. We'll add some new stuff in a second. Okay, so let's go self. Just being mindful of that video that I made recently saying don't read code exactly as it's written. This is a bad habit of mine. I'm trying to stamp that out. So anyway, good. The swap chain will be cleaned up. The next part is we need to know when are we going to need to check and recreate the swap chain. So if I look through the render function, where are we? This bit here. So at this stage, we are acquiring an image from the swap chain, which means we're working with the swap chain, which means that that's the part which might be throwing an exception. So we'll put it in a try except block. Okay. Side note, I created a sort of a singleton class in the logging module, which has these. So this is basically just checking under the hood. This will check whether it's running in debug mode and print it down if it is. It just sort of simplifies things a little bit. Okay, so we have that, and then there's another point where we're going to be messing with the swap chain, and that is when we present. So if we go to present an image on the screen, and the screen doesn't exist because we've minimized it, then that's going to be an issue. So over here, we will try to present to the screen, and if that fails, then yeah, we'll recreate the swap chain. Okay, so we'll just give that a shot. Alrighty, it's working, and we minimize it, and it sort of triggers twice. That's interesting, but the important thing is it's triggering at the right spot, so that is good. Okay, so now we can go and actually recreate the swap chain. Now I'm just going to go self. Okay, and we're going to return at this point because there's kind of no further work that we can do on this. So in both cases, we're going to call that function. All right, so let's make that function. So here we have make swap chain. Okay, so hopefully I haven't messed things up too much. Those should be the main components. Yeah, and we don't need to create the other. So when we did this for the first time, a lot of background objects needed to be created in a certain order, but now those background objects exist and we can just go through and make these in one go. Okay, so if we run this, it is doing its thing, minimize it. Okay, and we get an error, it would seem. Is the window gone? Yeah, the window's gone. We got an error. Okay, so validation error. Where are we? Required parameter, render pass begin, frame buffer specified as null. So this is a bit weird. This is very weird. So it seems like the engine is still trying to work while we're destroying the swap chain. I mean, we've destroyed a frame buffer and it's saying, bro, what's the frame buffer? So it definitely seems like it's still trying to do work. So what we can do is before we do anything, we can wait for the device to idle. In other words, just let it do its thing, and then we'll worry about that recreation stuff. Okay, so we minimize. Maybe I did mess something. Oh, am I not creating the frame buffers? Okay, that totally makes sense. Let me just comment that out for now. I just want to see the effect here. So we make a swap chain. Take two. There we have it. Minimize it. Okay, so the program is still there. It hasn't crashed, but we do get a validation error. Yeah, this is interesting. Width must be greater than 0. So that's because I've minimized it. It's trying to create the swap chain down here when it has a width and height of 0. So if we bring it back, yep, it works. Minimize it, error. Okay. So let's also go to the app and show the other case. When I created the window, I set its resizability to false. Let's set it so now we can resize it. Give it a second. Yep, good. I am obsessed with syntax highlighting. I don't like it when it's not working. Okay, so here we have it. Now we drag and let go of the mouse, and it recreates. We drag, we let go of the mouse, and it recreates. And so on and so on. But I think if we sort of bring it back, we might find we're still getting some errors. Okay, the fence is in use. Now this is the sort of error that we would get if we were not letting the device idle out before doing its stuff. So now we get it, minimize it, maximize it, whatever. And if we go back and look through here, it's a little messy, but we're not getting any errors. We are not getting any errors. Okay, that is great. So let's run this again, and we'll try the other type of resize, which is minimizing. Nope, we're getting some errors. Okay, so it turns out there's sort of a quick fix for that. And that is to stall until the width and height actually have a valid value. So let's go set these to 0 and then keep waiting. Okay, so this loop will go forever while it is minimized. Let's give this another shot. Okay, so here we have it. We can resize it as normal, and that works. Hey, side note, on a lot of, you might be expecting that as we sort of expand this, that this scene will sort of stretch out to fit the whole window. It doesn't. Why do you think that is? Turns out it's because we are sort of overriding these triangle positions with that model matrix. So no matter what, their world position is over here. Doesn't matter what size the window is. Anyway, because we're not applying a what am I thinking? We're not applying a view or projection. So they're sort of, there they are. They're there. That's a world position. Okay. But what I wanted to get at was, now we have that, minimize it. It's logged that out. It's waiting. It's waiting right now in this loop to have a valid size. So then we bring it back and it logs out all this stuff. We recreate the new swap chain and there we have it. So there we have it. A pure, stable, windowing system. Alrighty. I hope you enjoyed that, and yeah, have a good one. Bye.